Irrigation and infrastructure. It's hard to overestimate how important the foundational elements of a golf course are. Uh, you know, the evolution of golf from the Scottish linksland, where golf just naturally kind of evolved on turf with natural rainfall, natural drainage, natural forms, where people figured out how to play an entertaining game on, to the modern era where everything virtually of a golf course is not a natural component, it's an engineered, maintained component. Nothing is left to chance really anymore with respect to drainage and irrigation and greens construction and all the elements of golf course. So as we go through this section, I think the point will be fairly clear that our golf course foundation is aging and is showing signs of cracking, if you will. So we're gonna go over some components of the irrigation system specifically, and as part of the overall, I guess, foundation that we're going to talk about is kind of everything that's engineered on a golf course and that has a limited lifespan. Greens, USGA greens, the whole definition of a USGA green is one that is engineered. It's designed a certain way. It's designed to function in a certain way. And it has a limited lifespan. Our greens are basically 20 years old now. And so that infrastructure, if you will, has to be evaluated. The grasses that we play on, they don't die in the same way or fail in the same way that you talk about, a cracked foundation, but it's similar in the sense that genetics and improvements in turf grass don't stop, and we clearly are not playing on the best grasses we could be. Bunkers. We redid bunkers now about 10 years ago, and the engineering, the re-engineering that we put into those has been highly successful. They used to, if you recall, hold water, wash all the time, inconsistency between bunker to bunker. We've kind of fixed most of those issues by addressing the infrastructural challenges that we had with our old bunkers. But those have a lifespan. So this section is basically going to look at irrigation to start with, and then the other elements of a golf course infrastructure, and I think get you up to speed on where we are. How much life span do we have left in our foundation? Well, as promised, we're going to talk about irrigation first and an overall discussion of golf course infrastructure. And I'm going to try to do a pretty general discussion. We won't do a lot of nuts and bolts. In fact, I'd like to talk as much about kind of the concept of what you're trying to accomplish with modern irrigation and how that's done as much as anything. So one of the things right off the bat that is in the 20 years since our original irrigation system was built and now, that has changed fundamentally, and I would almost guarantee will be even more important in the next 20 years, is the efficiency of golf course irrigation as a criteria. That is to say, wasting not one drop of water, if possible, in irrigating your grasses to the condition and the level that you want them to. And there are a variety of ways that that's accomplished, and much of the development and improvement in irrigation the last 20 years has revolved around the more efficient use of water, because it is not just in Texas, all over the country, more and more and more important in evaluating irrigation, and in a very general sense, a societal sense, of people looking at golf courses and asking themselves questions about, do we want them? Are they good stewards of the land? Are they good stewards of the water? And we always want to be able to say with some confidence that the answer is yes. So we're going to talk about that. We're going to talk about how that is accomplished, and hopefully by the end of this, you'll have some sense of how modern or state-of-the-art irrigation systems do a much better job being good stewards of our water than the older systems. Well, let me just kind of scatter shoot through this and just kind of touch on some high points here about irrigation systems in general. It's really what this slide was meant to be. Start at the top left. You can see here a system that has been designed with small pop-up heads to water basically these hill slopes surrounding bunkers. This is done more and more. If you go with this kind of style, a grass down style where you have hills like this is very difficult to irrigate, especially with larger heads like this. You end up with too much in the bunker or too much in certain areas, and the highs are always dry. And so this is a not uncommon feature of modern systems where, again, you're just trying to make sure you're as efficient with the water as possible. So you'd have very low volume here, irrigating in a very specific area. And we don't know our bunker styles with any direct kind of certainty right now, but it would be one of those things we'd certainly be looking at if they were appropriate. Next slide over. This is an example of how precise we get when we're looking at the efficient use of water. These are catch cans, or I guess plastic ones would be called something different, but this is a way of evaluating this sprinkler, putting out the vessels in a way, they just a graduated thing that collects the water and then measures how much is in there over a period of time, and then would determine how efficiently, how evenly the water across this area that this head is going, the distribution is. So this is a good way to evaluate nozzles. It's a good way to evaluate spacing. And in general, the closer spacing you have, the more efficient you can be with your water usage. So this is, again, the irrigation today is evaluated in a very precise manner to try to get it as good as it can be. Here's a little blurb here I just pulled out of a article talking about a superintendent evaluating a new irrigation system. After 14 months of operation with the new system, the results are dramatic. Comparing water use at the marsh course to the adjacent creekside course, which has an old irrigation system, the marsh course used 32% less water on a per acre basis. Akins, that's the superintendent, observes, "I've heard it said that more sprinklers use less water, and I wondered about that at first, but we're using less water. If I could do it all over again, I would do it exactly the same." Again, one of the things we will clearly do when we redo the irrigation system is go from a 90-foot spacing, which is a very old reference point or suggested spacing guideline, to 65 feet. And again, this right down here, to move to this, This is an example of how you lay out systems today. The most efficient way is a triangular pattern. This is just what irrigation specialists have decided or figured out over the years, largely by doing this, doing studies like this and putting it in squares or rectangles or triangles and determining when you're overlapping from this sprinkler head to another one, what's the most efficient way to get uniform water, and it appears that it's a triangular pattern. So this is likely to be the general way that our irrigation system would be laid out wall to wall in a triangular pattern. And you can even see here, our system actually is laid out from the edges of our fairways on 90-foot spacings and then just moves out. As you can see here, this doesn't even really incorporate itself into fairways. It's just filling in everything on the golf course from wall to wall. And if you're catching everything with this spacing, you don't need to worry as much about defining areas. Now on greens you do, and that's a slightly different thing. That won't be a triangular spacing, or it might be spacing that's slightly different. And then the surround heads that point out also may be different. But in general, this is the kind of grid that you will see on a modern irrigation system. So that's pretty much it. A little blurb here about another golf course that's implemented a irrigation system to help reduce water use. I also mentioned, included this because it says electricity and maintenance costs. I think there's a little bit of that in there. I think the big thing that you're trying to do in gaining efficiency and uniformity, and again, the criteria being used just what you need to maintain really good quality turf and not a drop more, is what modern irrigation systems are designed to do. Well, conserving water is good for everyone. A truism, but if there's one underlying theme to this tutorial on irrigation, it is that water conservation, locally, nationally, statewide, is going to become more and more and more a part of irrigating golf courses. I mean, it used to be the issue is just kind of watering your golf course, and you may have some expensive water involved there. But I think the scrutiny of using it efficiently and being a good steward of the water you have, and facing potentially restrictions on the water you have, is clearly going to be more and more involved in golf course irrigation from now going forward. So what's the criteria? Using only the amount of water necessary to create good playing conditions and not a bit more. How to use less water. There's two primary, I think, ways of doing that in general. I'd like to start with focusing on just kind of how you schedule your nightly watering. So I'm sure most of you are aware, 90% of the irrigation is done at night. Play is done. There's a little bit of time after play is done at night, and we can start watering the golf course. And then you've got a window there until 5:30, 6 o'clock when we get here to start preparing the golf course. So that's your water window, that 8 or 9 hours that you can put water down in. And in the middle of the summer, that can be, 100%, where you're using virtually from, let's say, 9 o'clock to 5:30 or 6, you're watering the golf course in that entire window. Let's say that's 100%. What you want to do night to night to night to night is schedule your nightly watering so that you replace what was lost from the day before and not a bit more. So that, again, you're being as good a steward of the water as possible. Then the second part of that is applying that water you put out. Let's say 550,000 gallons you put out one night. Applying that water more uniformly so that the water scheduled is distributed by your individual sprinkler heads only where it is needed, and I guess again as efficiently as possible. So the two kind of work together. The first part, scheduling your nightly watering, you're going to use your weather station that's on site. You're going to use something called ET, or evapotranspiration rate, which is basically a calculation. Your weather station would take temperature, humidity, wind, and calculate that and come up with basically a number which gives you a pretty good approximation of how much water you lost that day. You use that data. You would use in-ground sensors, as I mentioned before. We'll talk about them even a little bit later, which give you actual moisture readings out on your golf course in various locations. Put those two together and you're going to get some percentage of 100% that you water that night. And then you get to evaluate that in the field every morning. Again, modern systems would have iPads and things like that where you can take out in the field, you see a wet area, you see a dry area, first thing in the morning, your only other time really to water, and you can dial it up, dial it down, and really, 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 really dial in the individual run times of your irrigation system. And then the other part is, do you have the most efficient nozzles, sprinkler heads, spacing, we talked about before, to where when you put the water down, your uniformity, and this is something we'll talk about a little bit later as well, your distribution uniformity, or DU, is as good as it can be. So you put the two together and you're being a good steward of the water that you use. Well, how do we stack up to that ideal? It's not the worst by any means, but it's clearly not also the best. We're not at the top end of modern irrigation systems. We'll go through these just really quickly. If you've seen the infrastructure tutorial, you have noted that in general, the average length of the PVC system and irrigation system is somewhere around 20-25 years, and we are basically at that point. So we are more than likely entering the last stages of our current irrigation system just based on average age of the system and what normally happens to them. Another little deficiency we have is that our golf course was laid out with irrigation heads roughly 90 feet apart. Now, that's not true with greens, but in basically everything else, we have about 90 feet between our irrigation heads. The modern standard is more like 65 feet. The reason why that's so important is if you're trying to equilibrate, and get an even distribution across 90 feet, it's harder than doing it across 65 feet. Wind affects it more. It'll blow a 90 foot head a lot more proportionally than a 65-foot head because, again, it's trying to stretch out farther. And then the amount of control you have between areas, obviously. If you have a wet area, you have a little hill next to a low area. It happens a lot on a golf course. And 90 feet spacing. It's just going to be hard to raise the time on the hill slope and not have it water down into the valley where you don't want it. At 90 feet and 65 feet, it's just easier to dial in that. So the one thing we can't really change, the current spacing of our irrigation heads from the greens out is not optimal. Thirdly, this is related more to repairs and things we have to go through that you probably don't see, but trust me, we first of all don't have a valving system that was the number of valves really that you would have optimally to isolate your golf course. So ideally, you'd have a leak. You get out there in the morning, you either find a leak or you find one during the day. The smaller area you can valve off and not impact the rest of the system, the better off you are, for obvious reasons. You can repair it easier without shutting off the golf course. You could shut off a small part, water that night, do it that morning. You may even be able to wait and do it on a Monday when you don't have people around. We also have a lot of valves that have failed. It just kind of happens with brass or steel valves, 20 years old. We have a number of them that just don't work anymore. You can dig them up, you can fix them, but it's a big job if you're changing valves on large pipes, in the sense that you have to valve off. It's kind of winter work. You have to valve off big sections of the golf course between the valves, take the valve out, cut it out, put a new valve in there, do all the plumbing back to it. So we didn't start with really enough valves to be optimal to be able to isolate small areas, and B, we're having failure on some valves. So it's more and more difficult for us to, when we have a leak, to valve it off and not impact the rest of the golf course. Mentioned this, I think, a little bit. Our piping system is PVC, which is the standard forever. It's the white pipe I'm sure you're familiar with. It has basically a 25-year lifespan. The new standard, HDPE, high density polyethylene, is just a fundamentally different product. It's much thicker. It's much more flexible. Its burst capacity is much lower. Its ability to withstand heat and cold and shrinkage and heating up is much better. It's just clearly a much better technology. It's a 50-year lifespan. So it's not been the case until recently with HDPE that you could also say that your irrigation renovation is not only going to improve your system, but you're going to be able to push your piping system out into somewhat of a 40, 50-year lifespan, which, most people can't even really kind of conceive of. We're all likely to be gone, and it's our people that are coming after us that are going to be enjoying the fact that we're not having to go back into the irrigation system and repair a bunch of pipe. And finally, technical improvements to mention this before: weather stations, nozzles, in-ground water sensors. Our system, we don't have any of that. You can retro some of that on there, so I'm not suggesting you have to change your whole system to do that. It's not true. But the best way to obviously do it is in a comprehensive way. And if we do an irrigation system, which we need to do anyway, we would definitely be integrating all of the technological ways to water more efficiently that are out there available to us. Let's use these pictures here to amplify just a bit on the first bullet point of the previous slide, just kind of addressing age in an irrigation system and what happens with a 20-year-old system. Let's start here. I mentioned in the previous slide about components, aging components, and being difficult to find compatible components or switching out components when they break. It's a good example of that. This is the face plate. It's the thing you look at when you flip open those field controllers. It allows you to manipulate time and turn on stations, etc. This is the back side of it. Along with that is an OSM. It's a module that communicates between the field controller and the computer. If something here fails now, you can't get this faceplate anymore. It's obsolete. This is the faceplate you have to purchase now. And then the other part of that would be compatibility issue, is that this OSM will not work with this faceplate. So you have to buy a new OSM as well. So the expense when something goes wrong with an old faceplate is very high. And we've also had some failures recently that just are or I think as a result of age. This is our intake screen. This goes on the very end of our intake, the pipe that goes out into the irrigation pond. This goes on the end of it to screen out debris and leaves and anything that you don't want to get in your intake. This is about 2 feet across, so this is a big unit. This just collapsed and failed. We have a new one now made out of stainless steel. Similarly, this is a screen that goes on the bottom of the pump shaft that goes in the wet well. And this rusted out and failed this year. And then we have a one of our main pumps. We have 3 pumps this size. They're 75 horsepower pumps. They put out about 750 gallons per minute. And this one just recently failed, and we are in the process of replacing it. And as you can imagine, this is an expensive component. So in general, the point here is to just kind of amplify the aging system and the impact of that on your kind of maintenance budget and compatibility when you replace out. All right, let me briefly just describe how this HDPE is put together. Here you have a picture, a very large main line. So these are 2 pieces, piece here, piece here. Then this machine in between is basically the fuser or welder. So you can see here there's a wheel with some blades on it. First part of the operation, it's got it on both sides. This drops down, and then this is shoved this way, this is shoved this way, this rotates, and it trims perfectly square both sides, this side of the pipe and this side of the pipe. Then this is pulled out, and then a very similar looking thing, about the same size, a heating plate, is dropped down, and then the 2 are put together, and on either side of the heating plate is heated up for some period of time, and then that's pulled out, and then these 2 pieces are shoved together, resulting in this. This is a close-up of the weld. This is the bead from this side. This kind of came together, and this is the bead from this side of the pipe. And then this weld or fuse, when it is done, makes this junction as strong as the pipe itself. So again, completely different technology. Historically, using PVC, the weakest parts are always these unions, whether it's done with a glued weld or fittings or even ones that are bolted together. It's always a source of problem that the HDPE is essentially solved. Okay, a little summation here. Got a lot to review here, but a lot of it is stuff we've talked about before. I want to just kind of make the point of how sophisticated modern irrigation systems are and how much technically driven they are. We haven't talked about this. Here's an example of flow sensors that you put on the piping system in various places. You can see there are various sizes here to measure actual flow between through your pipes. And this can be really important information. It can help you optimize the flow of water hydraulically through your system. It can alert you to problems in your system if one of these is registering something that's not supposed to. It can tell you if something's clogged. It can tell you if you have a leak. So this is a fairly recent development in modern systems that gives you a lot of data, transmits it to the central computer automatically. In-ground sensors, I have mentioned those before. This is just a great tool. You take these, this is in a green, but I don't know that you'd necessarily put them there, but you could put them in tees, you put them in fairways, you put them in dry areas, you put them in wet areas. you put them all over, and it transmits wirelessly real soil moisture. And by doing that, an actual reading of soil moisture, when you combine that with, let's say, some of the data that the weather station is giving you with evapotranspiration rate and other things, you have a great kind of idea or calculation or way of knowing how much water you need to replace day to day to day. Takes just a lot of the guesswork out. Nozzle technology, this is another kind of thing. I've mentioned this before, but it's very important. Here's kind of a shorthand view of a standard nozzle and an improved nozzle. You can even see kind of visually the distribution just appears to be much more even here and uniform. In fact, it is, than the standard. This can be as much as 20% of what's called distribution uniformity improvement. Distribution uniformity is just a calculation of how evenly the irrigation water is spread over an area. So over 100 square feet, if you had perfect distribution uniformity, every square foot would get the exact amount of water. That never happens. We never get there. In fact, 80% is a great number on a golf course. But obviously, you can save a lot of water and make sure that you don't have wet spots and dry spots if your distribution uniformity is as high as it can be. And a lot of these tools, here's one, I've talked about, you have tablets now that you can take out into the field or your smartphone. And rather than go to irrigation boxes and things and turn them on and look around and try to see what's going on, you can just push on the screen the irrigation head you want to come up. It comes up, you watch it. You can change the run times without going back to the computer. It automatically uploads it to the computer, so you can dial in the field now, much better than used to be, optimizing your coverage. So long story short, this is just a good kind of review of all the improvements that we currently, with our 20-year-old system can't take advantage of, or could retrofit to an old system. But we have the opportunity, I think, with the new irrigation system, because ours is getting to its lifespan, and because we have more technological improvements. This should really be a break point, no pun intended, a watershed improvement in irrigation technology and longevity that should hold Colonial Country Club in good stead for many, 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 many years. Thanks.